Alright, so we're rolling into section 12.4, and at 12.4 we're talking about right triangles made up of tangents and how kind of tricks they can play on us and problems they can give us. And I'll show you an example from a practice books because I couldn't find another quick example that is challenging like the one in our practice book, so I'm just going to give you how to do that one here. Alright, so say they usually give us the tangent coming off of our circle like that, and then we'll have the hypotenuse of that tangent go out from the center of our circle, something like this. And in this situation, right, I'll get to that here in a second, I guess. And then the leg of our the other leg of our right triangle is the radius. But you may notice that a part of our hypotenuse is the radius as well. Okay, so let's label this thing in generic terms. Neutral color like purple here. Let's label this as say A, B, and C. Okay, in the past we've labeled triangles pretty generically to help us with Pythagorean's theorem and not get things confused too much. We've labeled this, it would be like the hypotenuse, and we just label this as H, right? And then we'd have like just be really generic and just call this a leg and call this a leg, right? Because ultimately it doesn't matter which one's a long leg or which one's a short leg. The equation would just be h squared be equal to, whoa, that's too big, be equal to the two legs squared. So, the purple leg squared and the blue leg squared. And there was no real reason to differentiate between the two. So that was kind of the way that we did that. Okay, well, when it's inside of a circle like this, AH here is equal to L. AH is equal to AB because they're both radii. So that's a little curveball they can throw at you. So like we have in the past in this thing, we write, the first thing we do before we plug in any of our knowns is write the relationship that we know in terms of our points. So in this scenario, we would write and set up our equation like this. It would be AC squared, so hypotenuse, equals AB squared plus BC squared. And then if they broke this down, or if the givens were broken down into, like the hypotenuse here was broken down into smaller sections, you might have to substitute and break AC down into those smaller sections and then algebra your way to your answer before you even plug stuff in. And recognize that this and this are congruent because they're the same length. So if they give you L, you know AH, right? If they give you AB, you know AH, because in this scenario, AB is congruent to AH, right, because they're both radii. Okay. So, and also if you have two triangles that interconnect, and you'll see here in a second, because of two circles that interconnect in you'll see what I mean here in a second, but those two triangles will be similar because of angle similarity. But I'll show you an example, a really tough example here from your books. So this is all just Pythagorean's theorem. You've all solved things with Pythagorean's theorem before. So and remember to rearrange stuff in Pythagorean's theorem. It's the hypotenuse. If you want to know the hypotenuse, it's just the square root of your legs, sum of your legs squared. So legs squared plus the other leg squared. Legs squared, right? And then if you want to, I'm going to go neutral color here. If you want to solve for a leg, right? That says hypotenuse. If you don't solve for a leg, you can't see that. So if you want to solve for, I'll put it over here, I guess. If you want to solve for a leg, any one of the legs, this leg or that leg, right? It's going to be equal to the square root of the hypotenuse squared. Hypotenuse squared minus the other leg squared. It doesn't matter which one, okay? So that is the relationships that you need to recognize and then plug your values in. So here is the question that I'm talking about here. Maybe I can zoom out a little afterwards. I can maybe scroll over and stuff while I'm highlighting so you can see better. Nice. So this one was a toughie, right? If you didn't really think through it too much, and you didn't reach deep into your tool bag for some other things. There's a couple ways to solve for it. I'll show you both. All right, so QR, some purple line, and it's equal to 5. That's equal to 5. And RU, I'll use pink. That's purple still. RU is 12. I should be using smaller font for this. RU, there we go. RU is 12. RU is 12. And UT, RU is 12, and TU or UT is 3. So we know automatically, let's go ahead and put our given that aren't really, not really given, but they're given. RT equals 12 plus 3, which equals 15. Okay, so we know that. Maybe we use it, maybe we don't. And we need to figure out that what ST is. We're trying to find out ST. Okay, so we have this other line segment length. I guess we'll use green. QU and SU. And we know that QU equals, well, it's two line lengths. This QU is going to be equal to 12 squared, or 5 squared, plus, it should have been green, but who cares, plus 12 squared, or 2 legs for this triangle, because this is right angle. Remember that tangents meet the radius at a right angle. So this is the hypotenuse right here. QU is our hypotenuse, right? So it's the entirety of the hypotenuse, so we don't need to worry about this line segment or anything. So QU is 5 squared plus 12 squared, and the square root of that. So don't forget to take the square root of that. So that's 5 squared plus 12 squared equals, take the square root of that, and that's going to be 13. So H, or QU, is QU equals 13. So this is 13. All right, so now this is where most people get stumped. Like, I don't know what to do. So, but if you notice, I have 2 vertical angles. So that's an angle there. And I have an angle here, and that's an angle there. So by angle, 2 triangles are similar. Similarity triangles. Their triangles are similar because of angle, similarity. Similarity. Okay? So there's 2 ways that I can do this. I can, because of their angle, similarity method, angle, similarity, I can set up a ratio. Okay, I'm trying to find ST, and its paired length is 5. Little over big. Okay, and it's another length on a little triangle that I know is 3. So it's going to go on top, and it's on the big triangle, its similar length is 12, so it's going to go on the bottom. Right, so I have this is my little, this is my little triangle, and this is little triangle, and this is big triangle. Okay, little triangle, big triangle. I set up my ratio to put little on top, little over big. Okay, you could have done little in this column and big on this column, and then the line segment length that you want to use. I use this is the long leg, or is it the short leg? Whatever, it's the purple leg. Okay, it's the purple leg. Okay, so that's what I use. It's I guess this one is the short leg. So it's the short leg that I'm using. Okay, so I gotta erase that L. Put confusion there. All right, so now I just rearrange this. As long as you set up your ratio correctly, you can rearrange this all for S. Always put in your fraction, always put your unknown on top. It makes the algebra easier. Okay, so ST going to be equal to, this is on the denominator. This is the denominator on the left side. It's going to end up on the numerator on the right side. So I'm going to put my bar over here. 12 and 3, make some room for the 5. And the 5 is going to end up sharing the numerator with 3. And there's our equation. So 5 times 3 is 15, divided by 12 is that. And that's going to be 1.25 equals 1.25. All right, so that is the one way to figure that out. So this is 1.25. Okay, if you're like me, you like to use the trig. I like trigonometry. This is the trig way. All right, so what is this angle? Okay, I have 3 line segments to work with. I like sine, right? Because tangent confuses me because they could be positive, they could be greater than 1. So I like sine. So the sine of theta, or the arc sine of this, would be the opposite over the hypotenuse. I like sine for some reason, right? So the opposite line segment for this one is going to be 5 divided by 12. 5 divided by 12. Right? That's going to be less than 1. It's using the opposite thing. Oh, that's wrong. Sorry. Oops. I almost messed it up. Glad I double checked. Whew. That would have been embarrassing. 5 divided by my hypotenuse. My hypotenuse is 13. Yeah, so that would have been opposite over adjacent, which would have been the tangent. So this is using the hypotenuse. This is 5 over, sorry, straighten that up. This is 5 over 13. So this is the sine, which is opposite over hypotenuse. Opposite over hypotenuse is the sine. And I'm going to use the arc sine with that ratio to figure out the angle. Right, so the 5 divided by 13, equals that. Yes, 5 divided by 13 equals that number. That number is a ratio. It's 513. So I could just be like 513, right, and do second sine. So that means that this angle, the sine of that angle, was 513. So that angle is 22.61986459, whatever, and it goes on for quite some time. So it's going to be approximately 22.61986 degrees. I'm just going to save this in my calculator because the very next thing is I'm going to take the the tangent of this, right? And what am I going to use a tangent? Okay, so I know that I'm dealing with the adjacent line segment of this angle. Let's zoom in. All right, so I have this line segment, and I'm trying to find this line segment. So opposite over adjacent, I'm using the tan function. Okay, so I'm going to say the tangent of my angle, I'm going to say my angle was, 22 of my angle. I'm just going to say theta, right? Because I don't want to write that thing down. I'm just going to say equals theta, right? So let me zoom out so you can see that a little. So that equals theta. I declared that. Okay, so I don't have to write it down a bunch. Of theta equals opposite over adjacent. That's the definition of tangent, right? Opposite over adjacent. And in this case, it's 1.2. Oh, it's my unknown. I don't know that yet. Right? I don't know that yet. It's my ST. That's the thing I was solving for. ST. Divided by the thing I do know, which was 3. Where'd my pen go? 3. All right, so now I need to get in my equation over here. So tangent equals the tangent of this angle, which I call theta, equals my opposite line segment, which I don't know, right? Divided by 3 equals my tangent of theta, right? So all I need to do is isolate my unknown by multiplying by 3. If it's on the bottom over here, it's going to end up on the numerator over here. So 3 times the tangent of theta, that's just a ratio for my angle. It's 5/13, right? For this angle, every time I have this triangle size, this angle is 5/13 when it's this angle, right? So when the ratio of this to that is 5/13, right? It's gonna be ST equals. So this is the angle. I haven't cleared for my calculator yet. Right? Remember, I did 5/13, and I did the arc tangent of that. So my ratio was 5/13. 5 divided by 13 to get the sine, and I used the arc sine to get my angle. Now I'm going to take the tangent of that. My tangent of that is 41.6. I'm going to multiply it by 3, and I get 1.25. So this equals 1.25. I know there's a lot of explaining, but if you understand it, look how easy that was, right? Oh, I need this angle. I'm going to use sine because opposite over hypotenuse. 5/13. Use the arc sine. Awesome. Now I need opposite over adjacent. That's tangent. Use the tangent of that times 3. Oh, that was 1.25. Man, that is some powerful stuff. Okay. So, believe it or not, these are effectively wrapped around the same concept. Similar triangles, right triangles with, the same angles, no matter how big they are similar triangles. And these are similar triangles. So, anyway, that's that one. And if you have a line for QS, all you got to do is, if you have all 3 lengths, if you have this length, you solve for QS using Pythagorean's theorem. Right? You have these 2 lengths, you solve for QS using Pythagorean's theorem. US. Solving for Pythagorean's theorem, then you add it to 3 and you get QS. Right? So that was longer than I wanted it to be, but I wanted to show you the way to do trigonometry because that think, is better than this. But you have your opinion, and I have mine. So anyway, hope you enjoy the rest of the videos coming up now.